Okay, welcome back. We're going to be having a look at the SQA 2019 paper 2. All right, let's get started. So, a charity distributed 80,000 emergency packages during 2018. This number is expected to increase by 15% each year. Calculate how many emergency packages the charity expects to distribute in 2021. So, looking at that, 2018 to 2021 is 3 years. We're looking at a 15% increase each year. So we're going to use the multiplying factor method. So the multiplying factor, since it's an increase, that's 100% plus our 15%, and divide that by 100 to get our multiplying factor of 1.15. So in order to use this, our 2021 number of packages is going to be our 80,000 multiplied by the multiplying factor to the power of the number of cycles, in this case 3. So we type that into our calculators, so we get 80,000 times 1.15 to the power 3, which comes out to be 121,670 packages. Okay. Moving on to question 2. Find p bar, the magnitude of the vector p, 6, 27, and negative 18. So the magnitude of vector p there is going to be the square root of each of these terms squared. 6 squared plus 27 squared plus negative 18 squared. So we get, and don't forget your brackets around that negative, because a negative squared becomes positive. So we get 6 squared plus 27 squared plus, I'm just going to type 18 squared there, just to make it easier on my calculator. So we are looking for the square root of 1089, giving us that the magnitude then is 33. And vector has no units here, so it's just a number 33 there. Question 2. The diagram shows the triangle PQR, where PR is 45 centimeters, PQ is 70 centimeters, and the angle between them is 129 degrees. Calculate the area of the triangle PQR. So since we have two sides and an angle, we're going to use the formula from the formula sheet of the area of a triangle. A equals a half AB sine C, which we know A and B are two sides of the triangle, and C is the angle between them. So the area of this particular triangle, A, is going to be a half times 45 times 70 times sine of 129. I'm going to move this over so it's a little less. Oh. Sorry, crashed the file there. All right, so carrying on. Grab back to our nice pen. Move that over to there. All right, so the area then, pop all of that into our calculators. Remember, you can use 0.5 on the calculator rather than a half if you're more comfortable with that. A half times 45 times 70 times sine of 129. Do check that your calculator is in degrees mode. It should have a little capital D in the top of it. So our area here comes out as 1224.004 ... which, since all of these are whole numbers, I'm going to round to 1,224 centimeters squared. Be careful of your units. Our lengths here are in centimeters, so our area will be centimeters squared. So again, this is just using the formula straight from our formula sheet. Carrying on. Question 4. A sesame seed weighs 3.6 times 10 to the negative 6 kilograms. The weight of a poppy seed is 8% the weight of a sesame seed. Calculate the weight of a poppy seed in kilograms, giving your answer in scientific notation. So what we want to do then, our poppy seed, seed is double E, is going to be 8%, which is 0.08, of the 3.6 times 10 to the negative 6 weight of the sesame seed. We can pop that into our calculator. Alternatively, we can divide by 100 and multiply by 8, but this does the same thing. 0.08 multiplied by 3.6 times 10 to the power negative 6, use the negative button for that, is equal to, and change that to a fraction. Since it's the calculator paper, it actually gives it to us in standard form on our calculators. 2.88 times 10 to the power -7, and our units are kilograms. The diagram shows a cone, this is question 5, sorry. The diagram shows a cone with a diameter of 6 units and a height of 8 units. The x-axis and the y-axis are tangents to the base. A is a point of contact between the base and the x-axis. B is directly above the center of the base. Write down the coordinates of A and B. Okay, so if its diameter is 6 units, that means that we are 3 units here and 3 units here. And what else are we told? Diagram, it's a height of 8 units, so we've got 8 units up to B here. So in order to get to, where are we? In order to get to A, firstly, so A, we're going across the x-axis by 3 units. No units into the y-axis, and since this is three-dimensional, no units in the z-axis. B, we're going to go 3 on the x-axis, then 3 in on the y-axis, and then 8 up on the z-axis. Oh, done a z there. 8 on the z-axis. The two coordinates are all we're asked for here, and this is just your understanding of 3D coordinates. Don't forget, since it's 3 dimensions, you should have the third coordinate in each. Question 6. Solve the equation 3x squared plus 9x minus 2 is equal to 0, giving your answer correct to 1 decimal place. Your clue here, giving your answer correct to 1 decimal place, should tell you that we're going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now that is on the formula sheet, I just forgot to put it on this page, but when I learned it, we had to memorize it. So, if we have a look, we've got 3x squared plus 9x minus 2 is equal to 0. A, B, and C, although those should be little a's and b's. My C I can kind of get away with, A and B. So if we pop these numbers into our formula, we get x is equal to negative 9 plus or minus the square root of 9 squared minus 4 times 3 times negative 2 all over 2 times 3, which is negative 9 plus or minus the square root of 81 plus 24. Notice that the double negative there gives us the plus, so 105 over 6. Alright, so we're going to have two answers here because we're going to have the positive and, the plus answer and the minus answer. So we get x equals, we pop this into our calculator, we're going to start, so we get negative 9 plus the square root of 105 divided by 6, all divided by 6. Sorry, gives us 0.207 dot dot dot, which gives us that x is equal to 0.2 because we want 1 decimal place. And we also get, so or sorry, no, instead of or we get and, because this is 2 roots. So and we get that negative 9 minus the square root of 104, oh sorry, of 105, and then divide that by 6, and that gives us negative 3.207 dot dot dot, which to 1 decimal place is negative 3.2. Again, no units there, but we do have two answers, x equals 0.2 and x equals negative 3.2. Okay, question 7. The triangle XYZ is shown below. So we're given the three sides of this triangle and we're asked to calculate the size of the smallest angle in the triangle. Now, three sides and you're asked to calculate an angle, that's the cosine rule. Specifically, it's the angle form of it, which is this bit here. Okay, so if we want the smallest angle is going to be the angle opposite the smallest side. In the same way that on a right angle triangle, the 90 degrees is the biggest angle and the side opposite is the hypotenuse, the biggest side, we can say the reverse is true. So the smallest side, the 6.3, is going to be opposite the smallest angle, this one here. Okay, so if I relabel this just for convenience, so say A and little a, B and little b, and C and little c, just to relabel it in the same way that our formula is, then cos A, or in this case cos Z, is going to be equal to, so we need 8.5 squared plus 7.2 squared minus 6.3 squared all over 2 times 8.5, 7.2. Now, we can work all that out and then take the inverse cos of it, or we can do that in one step and we get that z is equal to, so we take the inverse cos of that function. So we get 8.5 squared plus 7.2 squared minus 6.3 squared, and then divide that by 2 times 8.5 times 7.2, and that should give us a final answer there of 46.406 dot dot dot, which, since this is an angle, I'm going to say 46.4 degrees. Now, you can work that out in stages, or if you're confident with your use of the calculator, you can do that just all on your calculator, as long as you have this bit written down to show all of your numbers in the correct places. Okay, carrying on. Question 8. A traffic bollard is in the shape of a cylinder with a hemisphere on top. The bollard has a diameter of 24 centimeters and a height of 70 centimeters. Calculate the volume of the bollard, giving your answer to 3 significant figures. So what we've got is, if we just look in this in profile, is a cylinder with a hemisphere on top. It's 24 centimeters in diameter and 70 centimeters in height. Now, since it's 24 in diameter, that means it has a radius of 12 centimeters, which gives us the rest of this height here to be 58 centimeters. And from there, we can calculate the volumes. So we know from our formula sheet again that the volume of a hemisphere is going to be half the volume of a sphere, which is 4/3 pi r cubed. And the volume of a cylinder, which we just know, is the area of the face, because this is a prism. A cylinder is a circular prism, so the area of the face is pi r squared, and we're going to times that by the height, which is that 58. So our total volume is going to be those two added together, the hemisphere plus the cylinder. So knowing those two formula and knowing all of the numbers that I need for that, so r equals 12, and in this case h equals 58, we can do that in one nice big long formula. So the volume total is going to be a half times 4/3 pi times 12 cubed plus pi times 12 squared times 58. Now, remembering to use your brackets effectively will let you type that into your calculator in one go. And remember, we can also use 0.5 instead of a half. Times, I like to use 4 divided by 3 inside a bracket for 4/3. So I go 0.5 times brackets 4 divided by 3, close that bracket, times pi times 12 cubed. Remember, that's cubed, not squared. And then I add to that pi times 12 squared times 58. Now, if you type that into your calculator all in a oneer, remember, BODMAS tells us that multiplication will happen before addition. So you should be fine with that. It pops up as 29857.696 dot dot dot. We're asked for 3 significant figures. So we get that the volume total is 29900 centimeters cubed. And that's our 3 significant figures. Question 9. Georgie had her roof repaired. She was charged an extra 2.5% for a late payment and had to pay a total of £977.85. Calculate how much she would have saved if she'd paid on time. So she actually paid 102.5%, which was 977.85. So really what she wanted to pay was 100%, so 100% is going to be 977.85 divided by 102.5. That'll give us what 1% would be, and then we'll times that by 100. So using our brackets again, so we get 977.85 divided by 102.5, and then times that answer by 100, and we get that she should have paid, our 100% should have been £954. Now we want to know how much she would have saved. So the saving is going to be 977.85 minus the 954. Okay, so 977.85 minus 954 gives us a saving of £23.85. Don't forget your pound sign because it's money. Okay, we're about halfway through the paper, so let's keep going. So express x squared plus 10x minus 15 in the form x plus p all squared plus q. So we're completing the square. Now there's the shortcut method where we could half this middle number and then test to find the correction, or we can use the expanding brackets method. Now the expanding brackets method is more commonly taught, but so it's worth seeing, and I'll point out the shortcut method as well. So x plus p all squared plus q. If we expand that, we get x squared plus 2px plus p squared plus q. Just breaking that double bracket, simplifying and adding on the q on the end. And then we compare that to x squared plus 10x minus 15. And we get then that 2p is equal to 10, so p must be equal to 5. We also know that p squared plus q is equal to negative 15, just comparing these, so like comparing this stuff together and comparing this stuff together. Okay, so by doing those comparisons, we're able to calculate that 25 plus q is equal to negative 15. So q is going to be negative 35. So we want to rewrite this in that form using these p and q's. So we get that x squared plus 10x minus 15 is equal to x plus p, so plus 5, all squared minus 35. Now the shortcut method for this is to look at this middle number here and half it. That goes inside the bracket. Then square that to get plus 25 and work out what you need to do to 25 to get back to negative 15. So 25 minus 35 gives us our negative 15. Is negative 15? What am I talking about? That should be 40, not negative 35. 40. Relying on a calculator too much, can't count. Minus 40 there. So we want to get from positive 25 to negative 15, we've got to take away 40. Okay, so carrying on. Negative 11. Oh, sorry, question 11. The diagram shows the course for a jet ski race. The course is indicated by the markers A, B, and C, with the total length of the course being 1,500 meters. B is 600 meters from A, C is 650 meters from A, C is due north of B. Determine whether B is due east of A. So what we want to know is this a right angle? Okay. Now this is a converse of Pythagoras question because we've been given a triangle, we've been given the three sides, and we're being asked, is that right angled? Because if A is east of B, and B is south of C, then that right angle is needed in there by our compass. Okay, so we know the total length of the course is 1,500 meters. So 600 plus 650 is 1,250, meaning that that can only be 250 meters. Okay, that should be in meters. Now, if that's a right angle, then so if ABC equals 90 degrees, then 600 squared plus 250 squared will equal 650 squared, just using our Pythagoras there. So I'm going to draw a line down here, and we're going to work that out. So 600 squared plus 250 squared is 4,22500, and 650 squared is 4,22500. So we can say, since 600 squared plus 250 squared is equal to 650 squared, by the converse of Pythagoras, ABC as an angle is 90 degrees, so A is due east of B. Yeah, so that way to north, that way to east. Oh, to west. What am I saying? Is B due east? Yeah, so that way is east, sorry. Yeah. B is due east of A. Silly Billy. Getting my directions the wrong way around. Right, 12. In the diagram, ABC is the sector of a circle, center C. DEF is the sector of a circle, center F. The sectors are mathematically similar. The area of the larger sector, ABC, is 2,750 square meters. So that's A. The area is 2,750. Calculate the area of the smaller sector. We want the area of this one. Okay, so if they're mathematically similar, that means that they share a scale factor. Now, we can initially see a side on each that's the same, so we can work out a linear scale factor. The linear scale factor is the new over the old. So if this is the one we don't know something on, it's our new. That must be our old. We're going that way. So that gives us 30 over 50, which is 3 over 5. And I can leave that there. Now, if we want to calculate the area scale factor is actually the linear scale factor squared, which is 3 squared over 5 squared, or 9 over 25. So with that in mind, the area of DEF is going to be 9 over 25 times 2,750, which is 9 over 25 times 2,750, which comes out as 990, and this is centimeters squared. So calculating the linear scale factor, using that for the area scale factor, and then using that to find our final answer with units. Now B asks us to find the angle ACB. So ACB is this angle in here. Now if you couldn't do A, you can still do B, since B has nothing to do with this scale factor initially. Okay? So what we're doing here, this is an arcs and sectors question. X over 360 is equal to the sector over the total area, which is pi r squared. Now we know r is 50, and we know the area of the sector. So, and pi is just a number, we want x. So what that tells us then is that x is equal to 360 times by, because I'm bringing the 360 up to the top here, times by the area of the sector, the 2,750. Divide that by pi, and our radius was 50, times by 50 squared. Okay, sorry about the bell there, we're recording this in a school. So, type that into our classroom, we get, into our calculator, we get 360 times 2,750. And that's 9,90000. And we're going to divide that by pi r squared. Where's pi? Pi times 50 squared which is 2,500 pi. So 990000 divided by that previous answer comes out as 126.050 dot dot dot, because it continues on. Calculate the size of the angle. Since this is an angle, we can say that that is 126.1 degrees. Carrying on. Find an expression for the gradient of the line joining the points A, 6, 9, to the point B, 4p, 4p squared, giving your answer in its simplest form. Okay, so what we've got is two functions, two coordinates here, and we want the gradient between them. And we know that the gradient is y2 minus y1 over x2 minus x1, which in this case is going to be 4p squared minus 9 over 4p minus 6. Okay, so we want this in its simplest form. Well, what we've got here then is, well, on the top there I think we've got a difference of two squares, and on the bottom we've got a common factor of 2. So if we look at the difference of two squares, that's 2p all squared minus 3 squared. And on the bottom, we're going to have 2 brackets 2p minus 3. So on the top, we get 2p plus 3, 2p minus 3. And on the bottom, we get 2 brackets 2p minus 3. The 2p minus 3's will cancel on each, giving us that the gradient there is 2p plus 3 all over 2. Which I suppose if you wanted to, you could write as p plus 3 of, p plus 3 over 2. P plus 3 over 2. Just taking the half out there. So I imagine either of those would be accepted. That one is a correct answer though. Okay, 14. Solve the equation 5 cos x plus 2 is equal to 1. So 5 cos x plus 2 is equal to 1. So 5 cos x is equal to 1 minus 2. So cos x is equal to negative 1 over 5. So x is equal to the inverse cos of, and I'm just going to use the positive here, 1 over 5. And we look at our cast table. All students take cos. And we had cos was negative, and cos is negative in these two quadrants. That's 180 minus and 180 plus. Okay, so what we'll get here is the x in here. And then we'll use that to get our two answers. So cos of 0.2 is, oh sorry, the inverse cos of 0.2 is 78.46 dot dot dot, which I'm going to have as 78.5 degrees. So x is equal to 180 minus that, 180 minus 78, oh sorry, 78, not 98, 78.5, and 180 plus 78.5, which gives us our two solutions to this, 180 minus 78.5 to be 101.5 degrees, and 180 plus 78.5, which is 258.5 degrees. Those are our two solutions to give that answer. Okay, question 15. Express 4 over x minus 2 minus 3 over x plus 5, where x does not equal 2 and x does not equal negative 5. This bit here just tells us that 0 is not on the bottom, as a single fraction in its simplest form. So we've got 4 over x minus 2 minus 3 over x plus 5. Now, if we want to use this, what we're going to have to do is cross multiply these. So multiply that, and multiply these. Sometimes known as the smile and kiss method here. So we get 4 x plus 5 minus 3 x minus 2 all over x minus 2 x plus 5. And now we can break those brackets, so we get 4x plus 20 minus 3x plus 6, double negative gives us the positive, over x squared minus 2x plus 5x minus 10, which comes out to the nice neat x plus 26 over x squared plus 3x minus 10. There we go. That's our single fraction in its simplest form. Question 16. Simplify a to the power 4 times 3a all over root a. Okay, so using our laws of indices here, what we have is a to the power 4 times 3a to the power 1 divided by a to the power 1/2. Okay, so we can rewrite that as 3a to the power 4 plus 1 minus 1/2. So multiplying together adds the powers, dividing subtracts the power, and that 3 comes out to the front there, which gives us then 3a to the power 2.5. So is it, no, sorry, 3.5. What about 4.5? 4.5. Just being silly today. So 3a to the power 4.5, which we could also write as 3a to the power 9/2. Okay, question 17. Expand and simplify showing you're working. So we get sine x plus cos x all squared. Break that double bracket and we get sine squared x plus 2 sine x cos x plus cos squared x. From trig identities, we know that sine squared x plus cos squared x is equal to 1 plus 2 sine x cos x. So 1 plus 2 sine x cos x. If you're familiar with the double angle formula, you could do that further, but we don't need to use that just now because this is just National 5. Question 18. Now this was a hugely written question, so I had to size it down to fit it on the page. The picture shows the cartoon snowman. The diagram represents the snowman. The head of the small circle S with diameter 15 centimeters. The body of the larger circle, center T. The point T is on the circumference of the small circle, and the points A and B lie on the circumference of both circles. Now I'm going to make this a little bigger and cut off the unnecessary information, just so that we can see this in a bit more detail and I can write on it nicely. So, point T lies on the circumference of the small circle. A and B are both on both circles. We know that the head has a diameter of 15 centimeters, so AB is 15, which means that that is going to be 7.5 in there. And since that's a radius, that's also going to be 7.5, as is that one, 7.5. So calculate CD, the height of the snowman. So what we need is this size here. Okay, now let's see, how can we solve that one? Well, that radius there, TD, is going to be the same as that radius there from T to B. Since that's a right angle, we can calculate that using Pythagoras. So TB squared is equal to 7.5 squared plus 7.5 squared. So TB is going to be the square root of that, 7.5 squared plus 7.5 squared. TB, which is our radius of the big one, is going to be the square root, oh, sorry, wrong button, square root of 7.5 squared plus 7.5 squared, close the bracket, equals, and we get then that that is equal to 10.606 ... which we're going to round there to 10.6 centimeters. So that is 10.6 here to get to there. Then we've got 7.5 and 7.5 for our 15 diameter. So CD is 10.6 plus 15, which is 25.6 centimeters in height. Most of the marks there is spotting this right-angled triangle and using the radius TB to calculate TD. Okay, last question. Katie? Katie? Katie and Mona are looking up at a hot air balloon. The diagram below, K, M, and B represent the positions of Katie, Mona, and the balloon, respectively. The angle of elevation of the balloon from Katie is 52 degrees. The angle of elevation from the balloon from Mona is 34 degrees. Katie and Mona are 350 meters apart on level ground. Calculate the height of the hot air balloon above the ground. Okay, so this is actually a multi-stage question, and it's the 5 marks last question on the paper. What we want is the height here. Now, in order to calculate that, what we're going to need to know is one of these two sides here. We either need KB or we need BM. Now, we actually have two of the angles, and we want an opposite side. And since we have two of our angles, sorry for the interruption there. And since we have two of our angles, we can actually calculate what the missing angle in here is. So angles in a triangle add up to 180. So 180 minus 52 and 34 make 86. So 180 minus 86 comes out as 94. So there's our 94 degrees in here. So we can use the sine rule, and I'm going to pick this side here, KB. Okay, that's the one I'm going to choose. Because we're then going to use not Pythagoras, we're then going to use SOHCAHTOA to find the height. So to find this one, we know that A over sine A is equal to B over sine B. So I want this one in here. So KB over sine 34 is equal to 350 over sine of 94. Multiply that across to get KB on its own. So KB is going to be 350 times sine 34, all divided by sine 94. So into our calculators again, 350 times sine of 34, divide that by sine of 94, gives us KB to be 196.195 ... I'm going to leave that number unrounded. And now we can calculate the height. So what we have is a nice right angle triangle here, where we know that this angle is 52. We've got our right angle. We want the height here, and we know this is our KB. So I've got my opposite and I've got my hypotenuse. So that's going to be SAW. So sine x is equal to the opposite over the hypotenuse, giving us then that the opposite h, so the height is going to be equal to, multiply that up, KB times sine 52. So our height there is going to be that earlier answer multiplied by sine 52. So keeping it in my calculator, I'm going to say times sine 52 to get 154.60 ... So our height then is 154, and this is meters, or 155 meters, sorry, rounding it up. I tell you what, 154.6 meters, just to keep things nice and accurate. And that should be the end of our question. Now that's the end of question paper 2, and a big thank you there to C3 N5R for sitting through this nice and patiently. Okay, thanks, goodbye.